These are the last two problems on the study guide. So on the study guide here, we're going to kind of keep this proof really tiny so that we can make sure it fits. So we've got our statements here, and then we're going to have our reasons. And so right off the bat, I am told for number 1 that angle 1 is congruent to angle 2, as well as angle 3 is congruent to angle 4. And that is given. So let's mark it. Angle 1 here is congruent to angle 2. Angle 3 is congruent to angle 4. So I'm trying to prove that this is an isosceles triangle. And since I'm trying to prove an isosceles triangle, think about the attribute of it. An isosceles triangle has two sides that are the same length, that they're congruent. So that's my goal, is essentially to prove it. And if you look at the figure, chances are I'm wanting to do the KJ is going to be congruent to KL, which would help me prove that this is an isosceles triangle. But I can't just jump to that right now. I really need to first prove that the triangles are congruent. And so look at what we have so far. We have an angle here and an angle here, and if I use the reflexive property, I can get that side right there. So let's do that. So I've got that segment KM is congruent to segment KM, and the reason is the reflexive property. Now that I've got the reflexive property, let's cover up this and look at one triangle. When we cover this up, what I see is that we've got an angle, a side that's in the middle, and an angle, which is enough information to prove that these two triangles are congruent. So number 3, I'd want to say triangle KMJ is congruent to triangle KML. Why? Because of angle side angle. So now that I've proven the triangles are congruent, what can I conclude from it? Well, I could conclude that these angles were congruent by CP/CTC. I could conclude that these sides right here are congruent by CP/CTC. But the one I'm most interested in is this side and this side here, because I need those to say that they're the same length in order to say this whole triangle here is an isosceles triangle. So number 4, I could say that KJ, segment KJ, is congruent to segment KL. Why? Because corresponding parts of congruent triangles are congruent. What does that mean? Well, once I've proven that these two triangles are congruent, their corresponding parts can also be said to be congruent. So now I could say, hey, these two sides right here are congruent, and if they're congruent, what do I got? I've got an isosceles triangle. So number 5, JKL, triangle JKL, is isosceles. And why can we say that? Well, that's that definition of isosceles triangle, which says that if you have two sides that are congruent, the triangle is isosceles. So if you have two sides that are congruent on the triangle, it's an isosceles triangle, definition of isosceles. Now, at number 20, I do not have a compass with me here where I'm doing the recording, so I want to just kind of give you the hints on how to do this. If you're trying to construct a congruent triangle using a compass and a straight edge, you really just need to do two main things. One, you need to copy this angle. So remember, copying an angle, you'd be putting that arc there, and you'd use your compass to measure the width here. So essentially, pretend the side's not here, and you could go to the mathopenref.com, and you could practice copying this angle. Once you copy this angle, so once you kind of have this whole thing going on, and you've copied it using that Math Open Reference where you're like, okay, I've got this, and then you had something over here so that you were able to say, all right, I've got my two places here. So now you've got your angle copied. What do? That's where you take your compass width and you measure how long this is. And you, without changing it, you swipe it on both sides here. So you get your compass width to say I'm copying both of these sides here, which gives you your points of intersection so that then you can connect them. So basically you did two types of constructions here. First step, copy your angle. So copy this angle pretending that this side is not here. And then once you copy the angle, just copy the segment here by measuring with your compass and swiping it both ways here so that you can say, oh, I've got my two side lengths.